Okay, here for 21, the change in temperature from 10 degrees C to 20 degrees C is found to double the rate of a particular reaction. How did the change in temperature affect the reaction? Well, the number of molecules with sufficient energy to react increased. Okay, all of the molecules in the flask started kicking around much, much faster, and therefore they had more energy to get over that activation barrier. For 22 here, this is the classic, you're trying to decide whether the reaction is 0, first or second order. If the plot of ln of A with respect to time is linear, then it is a first order reaction. Right, this is another one to talk through. So consider this reaction, 2 SO2s plus O2 gives us 2 SO3s. The forward reaction is proceeding at a certain rate at some temperature and pressure. When the pressure is increased, what might we expect to happen for the forward reaction? Well, if you notice this carefully, we have 3 moles of gas, 2 SO2s plus 1 O2 going to 2 SO3s. So we've got 3 moles of gas converting down to 2 moles of gas. So if you take PV equals nRT, you've decreased N. And so this is a way for the pressure to relieve itself. And so if you increase the pressure, the reaction will be driven to the right. So that would mean we will have a greater rate of reaction and a greater yield of SO3 at equilibrium. This is another one of those plots, is what we have to figure out first. So the plot of 1 over the concentration of NO2 as a function of time is linear. So that means it's a second order reaction, and the only one that's the second order reaction there is D. Rate equals K times NO2 squared.